Or would there have been? Well, who knows, because new research findings that focus on the influence of black holes were actually presented at the 245th American Astronomical Society Conference, and they may finally offer the long-awaited solution to this persistent mystery, the mainstream model of cosmology's salvation. A group of astronomers led by Dale Kiebsky of KBY College in Waterville had previously assembled the largest data collection on these tiny red dots, or LRDs for short, and discovered that a significant percentage of them included indications of gas movements characteristic of expanding black holes. Even though the large sample set was primarily based on publicly available Webb data, the identification method covered a wide range of red shifts. In fact, the experts not only focused on the 6 objects mentioned above, but also on numerous LRDs that appeared in large numbers around 600 million years after the Big Bang and abruptly decreased again about 900 million years later. During this process, the researchers discovered that almost 70% of the LRDs they had examined showed evidence of gas traveling at 1,000 km/s around a super-huge black hole, which is literally crying out for a normal accretion disk. To put it simply, the mass monster is fed by an accretion disk of gas and dust that spirals matter inward. This suggests that many LRDs may actually be expanding black holes, sometimes referred to as active galactic nuclei, when applied to the impossibly red spots of light. Additionally, Stephen Finkelstein of the University of Texas in Austin provides the following summary of the importance of this for general research. At some time after the Big Bang, these high-red shift sources essentially vanish. Regarding the much-discussed universe breakers, co-author Anthony Taylor goes one step further and claims that this is the solution to the universe-breaking problem for a very straightforward reason: where the majority of the light comes from. Accreting black holes and not from stars, there are significantly smaller light galaxies whose existence does not push our current models to their limits. If these are growing black holes, which we believe to be the case for at least 70% of the sources, it points to an era of hidden black hole growth in the early universe. Has the greatest astronomical dilemma of our time been resolved? Not quite. The whole truth also reveals that, in spite of everything, there are still many unanswered questions surrounding LRDs. This includes specifically why they don't happen at lower red shifts. One potential remedy for this is predicated on the idea that growth happens from the inside out. In other words, when a galaxy's star creation spreads outward from its core, less gas is deposited by supernovas close to the expanding black hole, making it less obscure. In this instance, the gravity monster loses its little red dot status after shedding its gas cocoon and turning bluer. Additionally, the LRDs differ greatly from the majority of black holes with smaller red shifts in that they do not radiate brilliantly in X-rays. However, specialists are aware that X-ray photons can be captured at specific gas densities, which lowers X-ray emission. For this reason, this feature of LRDs is also considered while compiling evidence in support of the notion of heavily shrouded black holes. However, theories must also be supported by reliable facts. As a result, astronomers are currently investigating a number of methods to learn more about the actual nature of LRDS. Researchers conduct a thorough search for additional accreting black holes in addition to examining their mid-infrared characteristics, since only then can they confirm the number of them that finally satisfy the LRD criterion. The presently unsolved LRD case should also be cracked with the aid of thorough spectroscopic investigations and specific follow-up observations. In this sense, Dale Kiebsky offers a more thorough explanation of the history of this kind of astronomical research. There are always 2 or more ways to explain the perplexing characteristics of the tiny red dots, he explains. Finding a balance between what agrees and what doesn't with models and observations is a continuous process. Although it hasn't been confirmed yet, the research findings once again show the revolutionary potential of the James Webb Telescope, even though the theory that the light from the impossible galaxies actually originates from the black holes. at their centers. After all, the most potent space telescope ever created appears to be able to solve the magnificent mysteries of the cosmos, in addition to revealing perplexing formations that leave researchers baffled. And now we'll tell you how to make sure you never miss another one of our videos. To be updated going forward, just give it a thumbs up and subscribe. We'll see you soon. The greatest astronomical crisis of our time was ultimately caused by the simple discovery of tiny red dots. This was understandable given that the red dots turned out to be extremely early galaxies that seemed far too enormous and massive for their development so soon after the Big Bang. Early galaxies were swiftly dubbed universe breakers since they blatantly contradicted our present notions. However, the James Webb Telescope has now aimed at the enigmatic objects once more, demonstrating that our conventional model of cosmology might not be as drastically incorrect as originally thought. If you will, the James Webb Telescope is doing a fantastic job of carrying out its main objective. Launched on December 25, 2021, into the depths of space, the Webb is poised to transform our understanding of the cosmos, and occasionally an astronomical revolution necessitates totally disproving long-held beliefs. The 10 billion device was created especially for infrared astronomy, and one of its primary functions is to study the first bright objects and galaxies to appear a few hundred million years after the Big Bang. James Webb is so strong that, in theory, it could detect the heat of a bumblebee on the Moon's surface from Earth. However, in reality, Webb hasn't added fluffy insects to the star charts. Instead, he has occasionally added mysterious structures that, based on our knowledge, shouldn't be there. It was already time to move on from the overwhelming pillars of creation after the profoundly moved global public had awed at the first breathtaking Webb photographs on July 22nd. Instead, examine 6 odd red specks whose light took more than 13 billion years to reach our earthly senses in the strange ring nebula of the galaxy. The dark things were concealed in the fine details of the pictures captured by the early release program's near-infrared camera. A closer examination of the reddish, shimmering structures after they were discovered by the team, led by Evo Lab from the University of Technology in Melbourne, showed that they had existed for 500 to 700 million years after the Big Bang. Essentially, the experts had anticipated finding only tiny baby galaxies at most for this early stage of the universe. Astronomers were even more baffled when they discovered that there were actually 6 galaxies that existed at the beginning of the universe, but were already as developed as our own. This is hardly surprising, as our models indicate that there was simply not enough normal matter at that time for galactic heavyweights the size of our Milky Way to have formed. This simply indicates that all of the objects that have been found so far have more than 10 billion, and in one instance even more than 100 billion, solar masses of stars. Given this, co-author Joel Ledger of Pennsylvania State University first believed that he and his colleagues must have made a grave error, but there was no way to determine why the conventional model of cosmology had been upset. As a result, Joel Ledger was forced to provide the following summary of the astronomical conundrum. Quotation, "We have found something here that is so unexpected that it poses a real problem for science." Additionally, his co-author and colleague, Erica Nelson of the University of Colorado in Boulder, added, "Even if only one of these galaxies is real, this pushes our understanding of cosmology to its limits. But why is that so? How did experts end up in a full-blown crisis after discovering 6 previously unexpected massive galaxies?" The explanation behind this is straightforward yet very important. Even the remote possibility that the purported galaxies might actually be other objects like dust-shrouded black holes offers an equally perplexing escape route. The only way to explain the existence of such massive galaxies at that time is to assume that the density of matter in the young cosmos was either 2 to 5 times greater than our models suggest, or that the early galaxies grew in a way that is entirely unknown to us. Because even in this scenario, there would have been a lot more stellar matter in the early universe than was previously thought.